Hello guys! In the last lecture, we see how accuracy metric gave us 99.8% score, even so we predicted every transaction as not fraud. In this lecture, we will learn better techniques to evaluate our model. So let's start with confusion matrix. Confusion matrix is a table that is often used to describe the performance of our classification model on a set of test data, for which the true values are known. To understand the confusion matrix, let's look at this table. The predicted classes are represented in the columns of the matrix, whereas the actual classes are in the rows of the matrix. We then have four cases. The first one is true positive. True positive is the values that predicted positive and are actually positive. False positive are the values that predicted positive and are actually negative. True negative are the values that predicted negative and are actually negative. Finally, false negative are the values that predicted negative and are actually positive. So in our example, true positive are the values that predicted fraud and they are actually fraud. And false positive are the values that predicted fraud and they are actually not fraud. True negative are the values that predicted not fraud and are actually not fraud. And finally, false negative are the values that predicted not fraud and they are actually fraud. The accuracy of the matrix can be calculated by taking the average of values lying across the main diagonal. So accuracy is true positive plus false negatives divided on total number of samples. Now let's import confusion matrix from sklearn and get the confusion matrix of our model. The code will plot our confusion matrix. If we draw the confusion matrix of our dummy classifier, we will get most of the predictions as true negatives and the rest are false negative. And that's because we always predict transactions as not fraud. But if we draw the confusion matrix of the logistic regression model, we see now that most of our predictions are true negative and the rest are distributed over false negative, true positive, and false positive. Now to make use of confusion matrix, let's introduce two new concepts, precision and recall. Let's start with the precision. Precision is the percentage of positive instance out of the total predicted positive instance. So we use precision to find how much the model is right when it says that it's right. Or in other words, how many of the predicted positive examples are really positive. We can calculate precision by dividing true positive over true positive plus false positive. Now the second concept is recall or sensitivity. Recall is the percentage of positive instance out of the total actual positive instance. So we use recall to find, of all the positive instance, what fraction we correctly predicted as positive. To calculate recall, we divide true positive over true positive plus false negative. Now you have to know that the higher your precision and recall, the better your model. But when one of them get higher, the other get lower. And for that, there is a concept called trading off precision and recall, which means controlling your precision and recall depending on your problem. And it can be achieved by using many methods. For example, setting a decision threshold of a classifier. Suppose we want to predict an instance as positive only if we are very confident. In this case, we have to set higher threshold, which will make our precision higher and our recall lower. Another example is if you want to avoid missing positive values. In this case, we should set lower threshold, which will make our recall higher and our precision lower. So you might ask, which metric should you focus on? The choice of metric depends on your business objective. For example, if you had spam filter problem where the positive class is spam, you should optimize the precision, because false negatives which are the spams that goes to inbox, are more acceptable than false positives, which are non-spam emails that is caught by the spam filter. Another example, if you had a fraud transaction detector, where positive class is a fraud. In this case, we should optimize recall, because false positives, which are normal transactions that flagged as possible fraud, are more acceptable than false negatives, which are fraud transactions that are not detected. So in our example, we want higher recall. Okay, so that's it for today's video, and see you in the next one.